James Webb Space Telescope, exploring the universe in infrared. The James Webb Space Telescope is one of the most important scientific tools ever made for exploring space. Launched in December 2021, it is the largest and most powerful space telescope. Designed to look deeper into the universe than ever before, unlike earlier telescopes, JWST uses infrared technology to see objects that are too faint, distant, or hidden by dust for other telescopes to detect. Its mission is to help scientists understand the origins of stars, galaxies, and even life itself. The discoveries made by JWST are changing how we see the universe and our place in it. The story of the James Webb Space Telescope began many years before its launch. In 1990, NASA launched the Hubble Space Telescope, which made many important discoveries about space. However, even before Hubble was launched, scientists were already thinking about the next big step in space observation. They wanted a telescope that could see even further back in time, to the very first stars and galaxies that formed after the Big Bang. In September 1989, NASA and the Space Telescope Science Institute held a workshop to discuss what should come after Hubble. More than 130 astronomers and engineers attended. They suggested building a large telescope that could observe the universe in infrared light. Infrared light is important because it can pass through dust and gas clouds that block visible light, allowing astronomers to see hidden parts of space and look further back in time. By 1996, a committee led by astronomer Alan Dressler recommended that NASA build a telescope with a mirror larger than 4 meters in diameter that could operate far from Earth and be cooled to very low temperatures. This would allow it to see the faintest and oldest objects in the universe. NASA agreed with this idea and began serious studies to see if it was possible to build such a telescope. The project was named the Next Generation Space Telescope at first. In 2002, it was officially renamed the James Webb Space Telescope, after James E. Webb, a former NASA administrator who led the agency during the Apollo program. The main goals of JWST were set to search for light from the first stars and galaxies after the Big Bang, study how galaxies form and change over time, understand how stars and planets form, and study planets outside our solar system while looking for signs of life. These goals could only be achieved by using infrared technology, which was beyond the abilities of the Hubble Space Telescope. The planning and building of JWST took many years and involved teams from NASA, the European Space Agency, and the Canadian Space Agency. The telescope needed to be incredibly precise and advanced to achieve its ambitious goals. The launch of the telescope, the launch of the James Webb Space Telescope, was a historic event. After more than 2 decades of planning, designing, and building, JWST was finally ready for space. The telescope was very large, about the size of a school bus, and weighing around 6,350 kilograms. So it had to be folded up to fit inside the rocket. On December 25, 2021, JWST was launched from the Guiana Space Center in French Guiana, South America. The launch used an Ariane 5 rocket, which is known for its reliability. The launch was an international effort, with NASA, ESA, and CSA all working together. The rocket took off at 12:20 p.m. GMT, carrying JWST into space at a speed of 40,000 kilometers per hour. After about 27 minutes, the telescope separated from the rocket and started its journey to its final orbit. JWST's solar panels opened up, and the mission control team cheered as the telescope began to power itself in space. JWST traveled for about a month to reach its final destination, a special spot in space called the Second Lagrange Point. It's about 1.5 million kilometers from Earth. This location is perfect for space observation because it is far from the heat and light of Earth and the Moon, allowing the telescope to stay very cold and see faint infrared signals from the universe. Once JWST arrived at L2 in January 2022, it began a complex process of unfolding its mirrors and sunshield, which took several weeks. Functions and benefits of the James Webb Space Telescope. The James Webb Space Telescope is a powerful tool with many important functions. Its main job is to observe the universe in infrared light, which lets it see things that other telescopes cannot. One of its most important abilities is seeing the first stars and galaxies. JWST can look further back in time than any other telescope, seeing galaxies and stars as they were just a few 100 million years after the Big Bang. This helps scientists learn how the first galaxies formed and how the universe changed over time. The telescope also studies how galaxies and stars form by observing their birth and growth. It can see through dust clouds that block visible light, revealing the hidden places where stars are born. This capability has already revealed thousands of new stars in places like the Eagle Nebula, providing a much clearer picture of star formation. Another important function is exploring exoplanets. JWST can study planets outside our solar system by looking at the light that passes through their atmospheres. This allows scientists to find out what these atmospheres are made of and even look for signs of life, such as water vapor or methane. The telescope has already captured direct images of exoplanets and discovered planets almost the same size as Earth. JWST also helps scientists understand the origins of life by studying the building blocks of life in space, such as water and organic molecules. The telescope has unprecedented sensitivity and resolution, with a mirror 2.7 times larger than Hubble's. It uses advanced technology, including a special sun shield that acts like sunscreen with an SPF of 1 million, keeping the telescope cool enough to detect faint infrared signals. Thanks to precise planning, JWST has enough fuel to operate for around 20 years. Major discoveries made by JWST. Since beginning its scientific operations, JWST has made 10 major discoveries that have transformed our understanding of the universe. First, the telescope discovered bright, massive galaxies at cosmic dawn, dating back to only 300 to 500 million years after the Big Bang. These galaxies are much bigger and brighter than expected, challenging what scientists thought about how quickly galaxies could form and grow in the early universe. Second, JWST found early supermassive black holes in the early universe, even though there was not much time for them to grow. Some of these black holes are as heavy as 1 billion suns, helping scientists understand how such massive objects could form so quickly after the Big Bang. Third, the telescope detected complex organic molecules in ancient galaxies. JWST found carbon-based molecules similar to those found in oil and coal on Earth, in galaxies more than 12 billion years old. This shows that complex chemistry began very early in cosmic history. Fourth, JWST discovered dust in the universe's youth. The telescope found dust in galaxies just 1 billion years after the Big Bang. This dust has a unique chemical fingerprint, suggesting it was created by the earliest stars, which helps explain how galaxies and planets form. Fifth, the telescope achieved direct imaging and spectroscopy of exoplanets. JWST captured its first direct image of an exoplanet called HIP 65426b, and discovered another exoplanet called LHS 475b that is almost the same size as Earth. It also detected molecules like methane and carbon dioxide in the atmospheres of distant planets, suggesting some of them may have water oceans and could support life. Sixth, JWST found potential signs of life on exoplanets. By studying the atmosphere of the planet K218b, JWST found possible signs of life, such as dimethyl sulfide, a molecule that on Earth is only made by living things, along with methane and carbon dioxide. This makes K218b a strong candidate for further study in the search for extraterrestrial life. Seventh, the telescope discovered rogue planet pairs called jumbos. JWST found dozens of pairs of Jupiter-sized objects drifting through space in the Orion Nebula. These objects do not orbit stars and may represent a new way that planets or failed stars can form. Eighth, JWST provided detailed views of star formation. Telescope's infrared vision allows it to see through dust clouds, revealing thousands of new stars in places like the Eagle Nebula and Rho Ophiuchi Complex. This provides a much clearer picture of how stars are born. Ninth, the telescope revealed intricate structures in nebulae. JWST showed never-before-seen details in nebulae, such as the Ring Nebulae, showing concentric arcs and clumps of molecular hydrogen. These findings help scientists understand the life cycles of stars like our Sun. 10th, JWST is helping to solve the mystery of the universe's expansion rate. The telescope measured the expansion rate of the universe, called the Hubble constant, and confirmed a higher value than some other methods. This deepens the mystery about how fast the universe is growing, and suggests there may be new physics yet to discover. These 10 major discoveries show how JWST is transforming our understanding of the universe, from the earliest galaxies to the search for life on other planets. Each discovery opens new questions and possibilities for future research. The future of the James Webb Space Telescope. The future of the James Webb Space Telescope is very exciting. Scientists expect JWST to make many new discoveries that will change our understanding of the universe. The telescope will continue to discover new worlds by studying exoplanets and looking for planets that might be similar to Earth. By analyzing the atmospheres of these planets, scientists hope to find signs of life, which could help answer whether we are alone in the universe. JWST will keep looking deeper into space and further back in time, helping scientists learn about the first stars and galaxies. There are many mysteries in space that scientists do not yet understand, such as the nature of dark matter and dark energy. JWST's powerful instruments may help solve some of these mysteries by providing new data and observations. The technology developed for JWST will help future space missions, and its discoveries will inspire new questions and missions. JWST is a global project showing what can be achieved through international cooperation. The telescope's findings will also inspire students and teachers around the world, encouraging the next generation of scientists and engineers. As JWST continues its mission over the next 2 decades, it will likely make discoveries we cannot even imagine today, adding to our understanding of the cosmos. Conclusion. The James Webb Space Telescope is a major achievement in science and engineering. Built to answer the biggest questions about our universe, JWST uses advanced infrared technology to see parts of space that were hidden before. The telescope has already made groundbreaking discoveries, from finding the earliest galaxies to detecting possible signs of life on distant planets. As JWST continues its mission over the next 2 decades, it will help us learn more about the universe and inspire people everywhere to keep exploring. The telescope represents human curiosity and shows what we can achieve through international cooperation.